Segment is 7.4, that is oxidizing and reducing agents. Oxidizing and reducing agents. See, I can tell you the example of oxidizing and reducing agents as a definition, but we will just go from an example. See, consider this particular reaction. The CuO, if copper oxide is getting passed by hydrogen, so what shall be the consequences? Here actually, hydrogen it reacts with copper oxide. So this product it will form copper plus H2O. Okay. Now we will split its half cell reactions and let's see how the half cell reactions are coming. Here Cu it is in actually 2 plus oxidation state in copper oxide, and when it is in the copper it is in the Cu in the 0 oxidation state. That means from plus 2 to 0 oxidation state, its oxidation state is changing. So what does that mean? That means copper oxide it is going to go to reduced. So this is reduced. Now we can consider the example of hydrogen. So we will see what is happening with the hydrogen. So when it is reacting with oxygen, here it is going to be H2O. So here the oxidation state of hydrogen it is 0. When it is a part of H2O, its oxidation state it is going to be plus 2. Right? So it is going to be plus 2. So x minus 2 is equal to plus 2. So here it is, we know it got oxidized, or else simply we can say here hydrogen it got oxygen. So any addition of oxygen it is going to be oxidation in nature, right? So I don't need to tell you so particularly. Now we have to see what is an oxidizing agent, what is a reducing agent. See, oxidizing agent is any agent which is oxidizing another substance. So here or reducing agent is any agent which is reducing another substance. Here copper oxide you have seen it got reduced, right? What reactant has brought up this reduction? Hydrogen. When it is reacting with the hydrogen, this copper oxide it got reduced. So obviously in this example H2, this is the reducing agent. So any agent which is reducing another substance is a reducing agent. Now we have to see what is the oxidation, which one is the oxidizing agent in this. See, copper oxide, what it has done to the hydrogen. See, hydrogen it has gone from 0 to plus 2 oxidation state. So I told you when the oxidation state is increasing, that means oxidation state is increasing, that means it is undergoing oxidation. So we can see what has happened to the hydrogen. So its oxidation is from 0 to plus 2. So this hydrogen in this case, copper oxide in this case, it oxidized hydrogen, right? It oxidized hydrogen, right? Because hydrogen its oxidation state changes from 0 to plus 2. So this is going to be an oxidizing agent. So definition is pretty simple. Okay. Reducing agent is any agent which is reducing another substance. Oxidizing agent is any agent which is oxidizing another substance. Now another very important definition. Okay. So little more elaboration. See what has happened to the Cu2 plus 2. What has happened when Cu2 plus is converting to Cu0? See, Cu2 plus it has to accept 2 electrons, then it has to change us into Cu, right? So which species has given this 2 electron? Which species given 2 electron in this? It is nothing but hydrogen, right? Hydrogen has donated these 2 electrons. So another elaborative or better definition of a reducing agent is any agent which is giving electrons. Any agent which is giving electrons is called a reducing agent. And other way, see here, for H2 to H2O, see, when it is going from 0 to plus 2 oxidation state, okay, so here actually 2 electron it will be losing. Thus that 2 electron it is supposed to lose from hydrogen, then only H2O will be forming, or else it is donating. H2 hydrogen has donated 2 electrons to oxygen. So otherwise, this copper oxide has in other ways, it has took 2 electron from hydrogen. Okay, sorry for that. 2 electron from hydrogen, copper oxide. So any agent which is taking up electrons, for example, copper oxide here, it is actually taking up electrons. So any agent which is taking up or receiving electrons, that is an oxidizing agent. Okay, so formal definition of oxidizing agent is it is the agent which is receiving electron. Reducing agent is it is giving electrons. Okay, so please keep this concept in mind. Now this oxidizing agent and reducing agent, these concepts, it helps with many reactions in order to identify whether a redox reaction has happened or it has not happened. So we will see one very good reducing agents as well as oxidizing agent. We will see here 3 examples. One is KMnO4, potassium permanganate. So this is KMnO4. This is an oxidizing agent. Potassium dichromate, K2Cr2O7. So these two are oxidizing agent. Now reducing agent is, let it be a reducing agent, potassium iodide. So this is going to be reducing agent. See, actually these reducing agents and these oxidizing agents, these oxidizing and the reducing agents, it helps with many reactions because the color change associated with these agents, it helps us to predict and understand what reaction is subsequently happening, what reduction or oxidation has happened or not. For first case, we will consider KMnO4, potassium permanganate. So let's take the example of KMnO4 now. See, KMnO4, the color of KMnO4, this is actually purple in color. Purple colored. Okay, I told you it is purple colored. So, KMnO4, it is actually this is purple in color. Purple in color, and if I write it's MnO4 minus, I just take out the K plus. This is in +7 oxidation state. +7 oxidation state. But one thing. This +7 oxidation state in MnO4 minus, it is not much stable. It always got a tendency to convert into +2 oxidation state. So when it is converting into +2 oxidation state, it shall changes into Mn2 plus. Okay, so it is supposed to be Mn2 plus. So KMnO4, when it is in MnO4 form or when it is in the +7 oxidation state form, this is actually purple color. But when it is in the Mn2 plus form, it's colorless. So this is the Mn2 plus form, that is the more stable form. That is actually the more stable form. This +7 state, this is in fact unstable. +2 oxidation state, this is going to be the stable form. So always the stability is a prime factor for most of the chemical or redox reactions. So please bear that in mind. So now what shall happen is, whenever MnO4, KMnO4, it is in reaction, it is in the surrounding with the, some reducing agent. When it is in the surrounding with the reducing agent, it will have a tendency to accept that electron, so that when it is accepting with the 7 electron, what shall happen? Mn7 plus, when it is accepting 5 electrons, okay, this can convert into Mn2 plus. So obviously, this KMnO4, it is always in a tendency to accept electrons. So this is a very strong oxidizing agent, because you can see from the reaction, it doesn't want 1 electron, not 2 electron, it is not satisfied with the 3 electron, it is unhappy with the 4 electron, it desperately wants 5 electrons. So it is a strong oxidizing agent, it always try to gain 5 electron from its surrounding environment, so that it can convert into Mn2 plus oxidation state, so that it will remain stable. How this KMnO4 is a good indicator of redox reactions is, see, I will tell you, when you consider this is a solution of KMnO4. So KMnO4, when it is a solution of KMnO4, I also need to tell you, this is actually purple color. This is actually purple color, and when you are adding some reducing agent, let it be any reducing agent, you can add sodium, or you can add any agent which is giving electron, any agent which is giving electrons you can add, let it be carbon monoxide, let it be sodium, let it be some usual potassium iodide. Okay, I will take the example of potassium iodide. Okay. So, or like any reducing agent, let it be any alkali. Okay, so any acid or whatever it may be, a reducing agent. So I am adding a reducing agent. So when this reducing agent is adding, through the reducing agent, this KMnO4 will be getting electrons. So here, keep on adding the reducing agent. What shall happen is, this Mn7 plus in KMnO4, it goes on changing Mn2 plus. So here the color in KMnO4, it is purple color. So after some point, once you added the reducing agent, after some point, what shall happen is, this solution, it turns to colorless. Okay. So, and you can understand, okay, this is what is happening. Now, I gave you some solution. I gave you some, maybe one beaker, which is having this is a beaker, this is some agent, let it be one agent A. This is again another beaker, this is again another beaker, that is agent B. Okay, we don't know whether it is alkali or acid or any kind of salt solution, we don't know, and our purpose is to find which one is the reducing agent, which is the reducing agent in this, that is our purpose to find. So easily what we can do, how the KMnO4 comes into use is, you can add some 5 drops of KMnO4. Okay, here also you can add 5 drops of KMnO4. Once you add KMnO4, this solution is supposed to becoming purple colored. The solution should become purple color, because KMnO4 color is purple. And think in this way, you added 5 drops of KMnO4 into A. There is no change in the color. Whatever was the color was A. When you added KMnO4 into A, you saw this solution, what change it is happening. You saw that the color is becoming purple. Here in second case, in B, you added KMnO4, okay, you added KMnO4, and you saw that this solution, it is remaining colorless. That means even after adding KMnO4, the color of the KMnO4, it is fading, it is not withstanding with this B. Now we can understand this B is the reducing agent, because only in the presence of a reducing agent, KMnO4 color will be fading. Okay, so the prime use of KMnO4 is, or any oxidizing agent which is colored is, to identify if there is a reducing atmosphere is in that particular chemical environment. So here we understood, okay, since the Kmn of our color is fading, we understood, okay, it is, here it is actually what? Here this B, it is a reducing agent, right? Another oxidizing agent similar to KMnO4, you can say a brother of KMnO4, that is potassium dichromate, K2 Cr2O7. See here, remember one thing, if I remove this K2, then I can write Cr2O7 2 minus. Here this chromium, as you are very aware, similar like many other transition elements, chromium, manganese, all transition elements, it all occurs in this multiple oxidation state. Chromium also it go to +3, +4 oxidation state. Manganese it go to +4, +7 and +2 oxidation state. See, chromium in these oxidation states, one of the oxidation state will be more stable. So in chromium, Cr2O7, that is O7 2 minus, this is in the +4 oxidation state. But remember, the stable form of oxidation state for potassium dichromate is a +3 oxidation state. Obviously, this Cr2O7 2 minus, it will have a tendency to shift from +4 oxidation state to +3 oxidation state. So this will be changing to 2Cr3 plus. Okay. So this is going to be the oxidation state, it is going to change. Now, same like a KMnO4, this is also a colloidal reagent. See, Cr2O7 2 minus, this is going to be orange color. Okay, and 2Cr3 plus, this is going to be green color. Okay, obviously, when in an oxidizing environment, okay, this solution it is going to change into another color. Okay, so it will change from orange to green color, right? Okay, here one thing we will see, like how this can be used for testing the presence of a reducing agent. Similar like KMnO4, you consider a beaker. Let it be, this is a beaker, okay, and you are having potassium dichromate in this K2 Cr2O7 2 minus solution in this. So see, you are well aware that here what is the reaction happening? What is happening with when it is changing from +4 to +3 oxidation state? One electron is getting added to the potassium dichromate, right? So when it is actually if I write here Cr4 plus, if it is accepting an electron, this is going to be Cr3 plus. This will change us into Cr3 plus. Obviously, this any agent which is giving electron, or other than in other words, any agent which is a reducing agent. Okay, so any reducing agent can bring about this change, +4 to +3 conversion. So if I add Cr2, if I add some reducing agent, okay, what shall be the occurrence is, say you are adding a reducing agent. See, now K2Cr2O7, so here the color is orange color. Okay, you are keep on adding this reducing agent. After some time, this color it is changing to this color. It changes to green color. Okay, this color it is going to change us into green color. And obviously, in the same way like a KMnO4, we can test for the presence of a reducing agent through this K2Cr2O7. Consider, this is a beaker which is containing some reducing agent. We don't know this is a reducing agent. We don't know whether it is a reducing agent or not reducing agent. Okay. Suppose you are adding this K2Cr2O7, potassium dichromate. See, the color of the K2Cr2O7 is orange color when it is in the +4 oxidation state, when it is in the normal state. So once you add this K2Cr2O7 into this, if it is a reducing agent, it will accept electron. Obviously, K2Cr2O7 that is going to get the electron. So its a color, it is changing to green color. Once if it is not reducing agent, this orange color it will remain in this beaker. orange color solution, it will remain in the beaker. If it is not a reducing agent, if it is a reducing agent, then this orange color, once it is fallen into this reducing agent solution, its color will changes into orange to green color. Its color is going to change. Okay, so this is what is another indicator. Potassium dichromate, it is going to be another indicator for a reducing atmosphere, and we can easily identify if a redox reaction is happening, if we are adding KMnO4 or potassium dichromate or any kind of indicator. These solutions, these potassium dichromate, KMnO4, these are all act as a redox indicators. We call it as redox indicators because we can easily say if there is a redox reaction is happening or not happening. Okay. By the way, this potassium dichromate, it is not a good reagent for those who are drinking and driving, because if you see the breath analyzer, so this potassium dichromate, it is a very strong oxidizing agent. What shall happen with this ethanol and its oxidation is C2H5OH, this get converted to, in the presence of KMnO4, this get converted to CH3CHO. This is actually, first one is ethanol, this is ethanol. Okay, so this ethanol, due to this conversion, it is very easy to, due to the color change. See the KMnO4, sorry, not KMnO4, potassium dichromate, K2CR2O7. So the potassium dichromate, it changes its color from, if the person is has consumed alcohol, it is going to change it to orange to green color. So easily you can comprehend, easily you can identify whether he was drinking or driving. So be careful and try to know the chemistry of potassium dichromate if you are drinking and driving. Okay, so now another reagent is which is a reducing agent is potassium iodide, Ki, potassium iodide. Okay, so I have already written the reaction what potassium iodide will be bringing. See, this is the reaction, hydrogen peroxide, if it is in the presence of a Ki, so and a little bit of acidic environment, this Ki, it get converted to I2. So I will write A into H2SO4, K2SO4, the overall reaction is K2SO4 plus 2H2. We shall see what is happening to the Ki. Okay, see Ki, this get converted to iodine. So if I write I minus, it is getting converted to I2. So I can write 2I minus. So potassium iodide, this is in fact colorless. There is no color is associated with the potassium iodide, but for iodine, this is actually purple color. Probably you have seen, all the halogens are colored. Iodine, it is purple color, bromine, it is reddish brown color, something reddish color, and chlorine, it is yellowish green. So by the way, iodine is also not an exception. Here one thing, see here, this is what is happening here. From what is happening to the potassium iodide, here it is in the -1 oxidation state. So -1 oxidation state to, it is changed into 0 oxidation state. So what shall happen? So in order to change into -1 to 0 oxidation state, it has to throw out one electron away. Then only the 0 oxidation state will be arising, right? So potassium iodide, if any reagent which is giving electron, which is throwing electron, which is donating electron, we remember that is a reducing agent. So potassium iodide, since it is having a tendency to release electron, this is going to be reducing agent. Okay, and so here you have seen, right, potassium iodide, it just changes into iodine, and this is a very good reducing agent. And suppose the same like KMnO4 and potassium dichromate we used for testing the presence of a reducing agent. Potassium iodide we use for testing the presence of a oxidizing agent. You think in this way. Suppose you are having, so this is a beaker. Yeah, so this containing one oxidizing agent. Let it be KMnO4. KMnO4. Okay. So this is an oxidizing agent. When it is KMnO4, that is going to be purple color. Okay, and you are adding potassium iodide. Ki, you are adding potassium iodide. Potassium iodide is actually, in fact, it is a colorless. So potassium iodide, we all know it is a reducing agent, right? So you are keep on adding potassium iodide, potassium iodide. You are adding, going on, adding. So after some time, what shall happen? This KMnO4, its purple color, it changes into, purple KMnO4, it will get completely oxidized to Mn7 plus 2, sorry, reduced it to Mn7 plus 2, Mn4 plus. Okay, Mn7 plus 2, Mn2 plus. Because this is associated with the 5 electron changes, right? Mn2 plus. So Mn2 plus, it is colorless. Now the next color, after some time you are going on adding. So this after some time the iodine will be remaining in the solution. So this solution it will come to a colorless point. It will come, the end point will be colorless. Slowly the purple color due to the presence of iodine it is going to come. So if I draw like this, okay, so this is KMnO4, you are adding potassium iodide. The color due to the KMnO4, it is a purple color, it is decreasing. This purple color, it is decreasing. A point in which there will be colorless, there won't be any color, and from there the purple color, it will be increasing. Here the purple color is increasing due to the presence of iodine, not due to the presence of KMnO4. Remember that. Okay. So of course, same like KMnO4, same like potassium dichromate. Here potassium iodide, it is a very good indicator for oxidizing environment. If any oxidizing environment is there, if you are adding potassium iodide, after some time its color will changes into purple color. Okay, like if you are adding into any reducing agent. Wow.